We started this problem in class, and I thought it was a good idea for me to go on and complete it. So we're to prove that if x is less than y, then x plus z is less than y plus z. And prior to now, we've taken this for granted. In all of our prior courses, we know that when we have an inequality, we can just add the same quantity to both sides of the inequality. However, now that we are in this course and we're just learning the postulates, we're always asking the question why, or how do I know that this is true? And we're always going to have to kind of justify statements. So that's what we're going to have to do. In this section, we're looking at postulates of integers, and so we're going to use those to help us to prove some of the statements that we've already taken for granted, such as this. So first thing we need to do is see, okay, well, what does it mean for x to be less than y? From our textbook, we know they gave us a definition that if x is less than y, then that means that y minus x has to be in the set of positive integers. What does that mean? Well, that means that y minus x has to be greater than 0. X, y, and z are all integers. So this is the information that we're going to use, or that we're going to assume, so that we can prove that x plus z is less than y plus z. So to begin our proof, we're going to assume that x is less than y. Then we're going to go directly and say, well, that means that y minus x is greater than 0. So let's look at this more closely. So what does that mean? That means that y minus x is greater than 0 implies, well, what does subtraction mean? None of the postulates that we've used involve subtraction, but they do define subtraction as adding the inverse, the additive inverse of a number. So y minus x is equal to y plus the inverse of x, or the additive inverse of x. And so that must be greater than 0. Well, if I were to add 0 to this, because I can, because 0 is the additive identity, and it would not change the problem. Well, by me adding 0, I can rewrite that 0 as a number plus the inverse of that number. Well, I'm going to choose that number to be z. Okay? And then from here, we're going to see where this leads us. This is going to be y plus negative x, or the inverse of x, I'll say, plus, well, the associative property says that I can regroup. I can easily, or I'm sorry, not the associative property. The commutative property says that I can switch these around. So the commutative property says y plus z plus a negative x plus a negative z. I'm going to back up and say this again. So we did use the associative property because I can always regroup. So instead of grouping the z and the inverse of z, I can regroup it as negative x, or the inverse of x, plus z, right? But then I can use the commutative property and switch the inverse of x and z around. And then again I can use the associative property to regroup, and this would be y plus z plus negative x plus negative z. Alright? In a previous proof that we did in one of our exercises, we found that negative x could be written as negative 1 times x, and negative z, or the inverse of z, can be written as negative 1 times z. All I'm doing is rewriting the left side of that using all of the postulates and the information that we received before. So this is y plus z plus, well, we know that we can factor out that negative 1, and we're left with that times x plus z. And what property are we using there? We're using the distributive property. It says that those two are equal. We have y plus z plus, well, when I have, by our definition, I know that this is just negative x plus z. Not from our definition, but from a previous problem that we did. And this is just the inverse of x plus z. So when I'm adding the inverse of x plus z, I end up with subtraction of x plus z. Well, by definition, the definition that we just used here, when we have, and by the way, this arrow should be a double arrow, goes if and only if. So x is less is a definition, so x is less than y if and only if y minus x is greater than 0. Here I have y plus z minus x plus z is greater than 0. So what does that mean? That means that x plus z is less than y plus z.